So we will see how a numerical is approached using the formulas and the theories we learned for partial balancing of a primary force of reciprocating engines. These are the formulas we learned. CMR is equal to B, where C is the fraction of reciprocating mass that to be balanced, and B is the balancing mass, and small letter b is the radius of rotation of balancing mass. And it is applied when only reciprocating mass are involved, and we have found out the horizontal component and vertical component of unbalanced force, and we have found out the resultant of the unbalanced force. And if the revolving masses are also given with mass equal to m1, then that above equation CMR is equal to B has to be modified into Cm plus m1 into R is equal to B. That is, we account for the balance mass of the revolving mass also. And let's consider this numerical. A single cylinder reciprocating engine has a speed of 240 rpm. That means n is given as 240 rpm. From this we have to find omega. And stroke is given as 300 mm and mass of reciprocating parts. That means m is given as 50 kg, 50 kilogram, and mass of revolving parts is given, that is m1, that is 150 kilogram. And if 2/3 of the reciprocating parts, that means the C, the fraction of which reciprocating parts needs to be balanced is 2/3. So 2/3 is C, and all the revolving parts, that means all of the revolving parts are to be balanced. Find balancing mass required at a radius of 400 mm. That means radius of balancing mass is given as 400 mm, 400 mm, and residual resultant force. So we have to find B and resultant FR. Those are the two things we need to find. So we know omega is equal to 2 pi into n, that is 240 over 60. So it will come as 25.14 radians per second. This is the first thing you have to find out. So omega you will get as 25.14 radians per second. 25.14 radians per second you will get as. Then we know when revolving masses are also given, the equation is Cm plus m1 into R is equal to B into B. Here stroke length is given, stroke is given as 300. So what will be R? R will be 150. R will be equal to 150 mm, and it will be 0.15 meters. So M is known, M1 is known, C is known, and B is known. To find B, so B will be equal to C into M plus M1 times R over small letter b. And everything is written here. So R is equal to 0.15 meters. So it will be 2/3 times 50 plus 150 times 0.15 divided by 0.15 divided by small letter b is given as 400, that will be 0.4. This is equal to 0.4 meters. So you will get a balancing mass as, if you do the calculation, you will get balancing mass as 26.38 kilogram. This will be your answer for the first question. It is not that complicated. If you know the equation, it is simple. And the residual unbalanced force. Residual unbalanced force when crank has rotated 0 degree. So theta is given as 60 degree from top dead center. So we know the equation for Fr or the residual unbalanced force as m omega square r times square root of 1 minus c square cos square theta plus c square sine square theta. Theta is equal to 60. Everything else is known. So if you put in m into omega is 25.14 square, r is 0.15, and square root of 1 minus 2 by 3 square times cos square 60 plus again 2 by 3 square and sine square 60. And if you find the answer, you will get resultant unbalanced force as 2849 Newton or 2.85, approximately 2.85 kilonewton. You can stick to Newton, you don't need to write kilonewton. So this will be your answer for the second one. This is a simple problem. Normally these kind of problems are asked from these sections. So try it yourself and find the answer. Thank you.